Well, good afternoon, everybody. This is Ian Trevethan. I'm the Education and Outreach Manager. I've never been able to get my title right. Education and Outreach Manager here at the Sternberg Museum of Natural History. And this is my friend Curtis.
You've never gotten that
I've never
right
gotten his
either.
name right. Curtis J. Schmidt, our Zoological Collections Manager. And we are here to bring you some really cool stuff about our ornithology collection. So I will let Curtis sort of introduce his subject here.
So before I get started, if Reese will show you some of the things that we're going to talk about today, I have to throw a disclaimer out there. For you parents of small children out there, we're going to be talking at least a little bit about a rather taboo subject, and that is going to be sex. You can't really talk much about birds without talking about sex in some way, shape, or form. So what I want you to do is probably you will need to define some terms like breeding and mating and things like that, you parents of smaller children. We're going to be talking a lot about that. So mainly what I'm going to show you today is a group of birds called passerines. That is the fancy way of basically saying songbird. The group of passerines and passeriformes are known as the songbirds. It's the largest group of birds out there. If you're out there right now looking at birds and bird watching and seeing things in your yard, most of what you're seeing are going to be these songbirds or passerines. What I'm going to talk to you about today is kind of a focus for students of the EcoMeet that are out there. So that's kind of what we're going to talk about, is talk about some of the things that they're going to be tested on in EcoMeet and show you some of the different things.
And as always, we encourage you, if you have any questions, put that in the comment section, and we will sort of look through them towards the end of our discussion today and try to answer as many as we can live. But if we miss them, or if you don't catch this while it's streaming live, you can always send us questions, and we do check our comment section on our feeds fairly regularly and try to answer as many questions as possible. So one other thing that I kind of wanted to mention, we kind of talked about this before we were filming. We in this part of Kansas are very fortunate to be in this location when it comes to birds. And why is that?
Right. Well, especially this time of year, we are located smack dab in the middle of what's known as the Central Flyway, which is a major migration corridor for most bird species. So as they're going from the areas where they breed up in the tundra, the Arctic tundra, northern Canada, places like that, and then they migrate south for the winter, down into the tropics. So we're looking at Central and South America mostly. And then, obviously, this time of year in the spring, they're going the opposite direction. So these are most of the things that we're seeing right now coming through. Lots of these migrants that are, we call those neotropical migrants, because that's where they spend their winters, is in the neotropics for the most part.
Do the wetlands that we have around here give us an advantage in that regard?
The wetlands are perfectly located and get tons and tons of these migratory birds. Lots of migratory birds. So as kind of a segue into what we're going to talk about today, for anything in the animal kingdom, there is basically one goal in life, and that is to spread your genes as much as you possibly can. So that is a theme that's going to be very common today as we're looking at all these things, is a lot of these birds, their ultimate goal is to have as many offspring as they possibly can throughout their life. So as we're looking at these, you're going to see there's a lot of variation within individuals. Okay? So some of them are going to be very, very healthy individuals. And typically in the world of birds, the females are the ones that make the mate choice. So they're the ones that are going to be choosing which male they want to sire their offspring.
So how do we define variation in the biological science? What is a good way to explain that to a more general audience, do you think?
Gosh, basically differences in physical characteristics. That's variation. Obviously, you can go all the way to the molecular level, the cell level, and look at variation. But the variation we talk about is in the expression of those genes. So how things look, the different expressions, the different colors, things like that.
So for example, if you were to look at me and Curtis, we're both Homo sapiens, male, but clearly we have some variation. We're not exactly alike.
That's right.
So there's that.
That's right, Ian.
So, that is one very generalized way of looking at it, but there can be all kinds of variation between male and female,
Right.
young and old, and obviously, in this case, different, I guess, varieties or subsets of different kinds of birds.
Right. So let's go ahead and start. We'll dig into that. The first thing I want to talk about is sexual dimorphism. And what I mean by that is the males look different than the females. And if you go back to what I was just talking about, the females are the choosier sex. They're the ones that are going to decide which specimen, which individual male they are going to breed with to create offspring. So they want to pick basically the sexiest male.
So
if that makes sense.
dimorphism means two
Right.
morphs or two shapes or two forms.
Right.
That's
So
what it means.
a couple examples we're going to look at right here. This is a brown-headed cowbird. Typically, when it comes to sexually dimorphic species, the females are very, very drab-colored. Uniform brown. Sometimes they've got nice speckling and banding and things like that, because their goal is to not be seen and not be captured. So they want to be able to blend in with their environment as best as they possibly can. Whereas the males want to be as showy and as sexy, if you will, as they possibly can. Now, this isn't the greatest example, but we do have some good examples that I'll show you. So that is a male brown-headed cowbird. It's also important to remember that the colors that we see are much different than the colors that the birds see. So to a female bird, this is probably much more stunning than it is to humans. So that's the brown-headed cowbird. But so if you look at these, you've got the very drab female and the rather colorful male. But also, when they raise their young, the young usually come out, whether they're male or female, looking just like the female. Because again, their job is to stay concealed. They don't want to be found, they don't want to get eaten. So they don't need to be flashy. The flashy is for reproduction. So until they reach reproductive age, they usually stay very drab and rely on their camouflage. This one right here, you can see is starting to molt. It's a young, immature individual, but it's starting to molt its feathers and come into its adult male, sexually mature pelage or coloration. So you can see that going on there. So it's important to remember that juveniles and immatures often look just like the females do, and I'll show you some more examples of that as well.
We have a question, just since you just talked about sexual dimorphism. Melanie is wondering, are there any species of passerines that showed sexual dimorphism the other way, with the females bright and the males dull?
Oh gosh, I'm sure there probably is, but off the top of my head, I can't think of one. Thank you, Melanie, for stumping the scientist. I'll think about that, and hopefully we'll get back to you here shortly.
Now, sexual dimorphism especially is tricky because there's so many different ways that can be expressed. So in this case, we're talking about color. We're also talking about different age stages.
Right.
We're talking about male versus female, but then you get into structural dimorphism and sexual size difference. And so there's so many things that you can explore. It's easy to
I know the answer is yes, because there are instances where the male is the choosier sex. I know that happens. I'm just struggling to come up with a good example of where that actually happens.
This particular kind of bird, do you think?
No, definitely not.
But there are cases in some kind of bird where the male is.
It probably, and definitely within the animal kingdom.
I wonder what kind of, biological force would be driving that. why would a male be choosier in this case than a female? What do you think? What would you hypothesize in that regard?
It all depends on who is protecting the high-quality resources, the high-quality habitat, the high-quality food, things like that.
So maybe.
And if those roles are reversed for whatever reason, then you're going to have those sexual dimorphism roles reversed as well.
So like, penguins, at least occasionally the males look after
They do.
the
For
nest
sure.
eggs or egg nest.
And there's lots of examples in the animal kingdom where the males do take care of the young. But I'm still trying to think of a good example of where the females are flashy and the males are not.
We'll have to.
I'm
we'll
just
have to get back
having,
to you on
I'm
that.
having a brain fart right now.
Melanie says maybe Jen can answer the question.
Anyway, back to the birds. So here's a better example of that sexual dimorphism from one of my favorite species right here. So this is one of the migrants that we were talking about that's coming through the area right now, the yellow-headed blackbird. So the male, very brightly colored. The female, as usual, very dull.
So that is a very, very,
Very brown.
striking.
Right, that is a striking difference. And this is a very healthy male. And kind of what I was talking about before, the reason why the females want to choose these really sexy males is because these are signals that they have a really good territory, a high quality habitat, lots of good food resources, just a healthy animal, very few parasites, things like that. So it's an indicator and a signal to that female that this is a very, very healthy male.
I would have thought he was a very, very dead male.
He is a very dead
He
male.
is now. But
Which
lasting legacy.
Which brings me to another thing I wanted to talk about, just briefly. We're talking about the collection right here, the ornithology collection. We've got about, probably 8,000 skinned birds in the collection. So basically, to prepare a specimen like this, you want it to look obviously as close to life as possible. So basically, the way that they do that is they make an incision down the belly, they part the feathers, make an incision, pull out all the insides, okay, bones and all for the most part. The only bones that are typically left in a bird specimen are in the legs and the feet, and then the skull.
Dissecting birds is one of the harder things I have ever done.
It's not easy, and I've actually never prepared a study skin of a bird, and I'm kind of intimidated to even
I've
try.
never done a study skin, but just trying to, for ornithology lab, dissecting, I think it was a pheasant that I was working on. And it was compared to all of the other specimens that I had ever dissected. Birds are really, really difficult. So this is almost an art form.
It's absolutely an art form. And to look at that, you can't even tell that that thing's been cut open and stuffed. And again, so once all that stuff's pulled out, they stuff it with cotton, which is what you see coming out of the eyeballs right there. And it is part of my job as a collections manager to ensure that these things are preserved as best as possible for all of eternity.
So you'd be mad at me if I put googly eyes on
I would be
birds?
very mad at you if you destroyed any of these specimens for any reason
Googly
whatsoever.
eyes, just the googly eyes.
I guess that would be it.
I'll resist the urge.
So that's another really good example of the sexual dimorphism. Another form of sexual dimorphism, which isn't too common in birds, and I don't even have an example right now, is where the females are much larger than the males. If you think about that, that's kind of a strange thing. A lot of people wonder, why is that? That's very strange. You find it in turtles, you find it in some snakes, things like that.
Some dinosaurs.
Dinosaurs, for sure, same difference. They're all related. The reason why is because they have to have as much room as possible for those eggs. They want to have the biggest eggs possible. They want to have the most eggs possible. So they need to have the bigger size.
So in some cases, when you're thinking about forming eggs, where does that eggshell come from? While the mother is picking the eggs,
Right.
for lack of a better word. Well, that would be one of the other, I think, good arguments for having like sort of a bulkier structure would be, in at least in some cases, having the resources to form those eggs.
Right.
Pull some calcium out of your bones in
That's
order
where
to
I
make
go,
the
yes.
eggs.
There you go.
I was being cryptic, sorry.
Eating more calcium and pulling calcium out of your bones.
There we go.
So if you come over here, here's some more striking examples of sexual dimorphism in another one of my favorite species, the scissor-tailed flycatcher. So these are good examples of both sexual dimorphism and species that migrate, because these things are showing up in Kansas right now. So these guys, as well
Is
as,
that a male?
this is a male.
Okay.
See, the male's got the really long tail feathers.
And then,
To use those, again, as a signal of its health to attract as many females as possible.
what does a female look like? Just,
And then this is a female. You can see there's not a whole lot of differences in the coloration of the bird, but the size of the tail for sure.
so that's an
This is the
example of
main
sexual size dimorphism, which is one of the things I was going on about earlier, about how the different versions of dimorphism happen or present.
But here's where it starts to get a little tricky, and people tend to forget about this. Things don't start out as adults, do they? They start out as juveniles. So this could easily be confused for a female scissor-tailed flycatcher, but it's just a young male. It hasn't gotten those long tail feathers yet. Tail feathers, by the way, are known as retrices for those bird nerds out there.
So, at least in paleontology, we would call this ontogenetic
Ontogenetic changes.
changes.
So let's compare
Variation.
the female with the juvenile male. Very difficult to tell the two apart.
So how would you?
You would cut them open and see if they have ovaries or testes. That's what I would do. Externally, I'm not sure on species like this. So a couple of the other guys that are coming through here, right back to their home summer residence, are some other flycatchers. The western kingbird, and most of you are going to be very familiar with these animals because they're all over the place right now. And the eastern kingbird.
He's got a really good flash of
So
color
these
on
are
his-
both flycatcher species, just like the scissor-tailed flycatcher. So again, these are migratory. So they're going way down to the neotropics of Central and South America to spend the winter months. Why do they do that, Ian? Why do things need to migrate? Some birds stay here.
My guess is they need a food source.
Absolutely. They are doing nothing other than chasing their food source. These things eat things that fly, insects, moths. They're flycatchers. So most of the species, if not all of the species that are migratory, and this includes bats as well, are leaving the area because their food source is no longer prevalent in the environment. So they have to go where the insects are going to be continuously active, and that's the neotropics, active year-round.
Why
So-
not just stay there though?
That's a fine question, but can you imagine how crowded the neotropics would be if every bird
Not a lot of resources.
from North America stayed in Central America?
So you would not be able to maintain your advertisement for how fit and
Exactly.
how great a resources you have if it was over-competed.
Resources would be quickly depleted if that happened, which is why they migrate during the summer months way up north to the tundra. Because now it's getting warm, there's insects there, there's fewer people there, so there's lots of better places to lay their eggs and raise their young.
Plus, the fact is really that as you get further north, the number of insects available seasonally is huge numbers. There's a huge food resource here that animals are going to want to take advantage of.
And why is that? Especially animals like this, like these flycatchers. Why is that? Why is there more insect availability further north, Reese?
Well, you start to it gets much warmer. You get a lot more sun and longer sun period. Like the days are much longer. In the tropics, the days are the exact same length all year round. And once you get further north, the days get much longer. And with warmer, you get a lot more water that's available. So you
There you
get
go.
water and sun, which allows insects to reproduce like crazy.
Yeah, lots of the things that these eat have larvae that live in water. So you think of areas like Minnesota, Canada, land of 1,000 lakes, or 10,000 lakes, whatever the hell it's called.
Sorry if anybody from Minnesota is watching here.
Right.
It's 10,000.
Lots of water.
We have 3 lakes here.
So we're looking at mayflies,
We had to
stoneflies,
make
all
them.
those different things, dragonflies, damselflies. All those have young that are in the water, developing until they come out, and then they get sucked up by the millions by these birds. So let's move on. Here's another great example of variation and sexual dimorphism. And this is also another species that is migratory and has recently shown up back here in Kansas. So this is the Baltimore oriole.
My favorite bird.
Yeah, I think my mom just saw one in her yard.
Beautiful, beautiful birds. If you see one of these, there's no mistaking what it is. So there's your really brilliant, very healthy male. This is what a female typically looks like. Again, quite drab. Not near as colorful as the male, because again, this is the one that's going to be choosing the individual to mate with. But also, if you look through here, these are pretty much all males right here. So you're looking at some of the variation there that those females are choosing from. So if you're a female, are you going to choose the really nice bright one? Or are you going to choose a younger one that's much uglier, if you will, that's not quite as sexually mature? You can definitely tell the variation there, and which few are going to be the ones that get the majority of the females to breed with them. And again, some of them are young, they're not mature yet, so they don't have that nice bright coloration yet.
The bright ones, are the Jim Palmers of the world. That's why, they're the best baseball players for the Orioles.
Okay, yeah.
That's why I
We'll
like
go with that. How about Cal Ripken?
Cal Ripken was definitely a bright orange Oriole.
That's more my age. So here's another one that shows variation. This is one of our very common winter residents. This is called the Harris's sparrow. And if you look at that, you can see there's a ton of variation in there. Now some of those are females. Most of the ones on this side are male. The females are over on this side. You can see they retain some of that as well. But what the females are looking for here is that nice big black bib. So the bigger that is, the further down on the chest it goes, the healthier that individual is, the better its genes.
So Dr. Fink says reverse size dimorphism is also seen in birds of prey, hawks and owls.
Well, there you go.
And then
Spoken from a true ornithologist.
Jen says,
Okay, so Jen Rader is answering the question. For a shorebird, phalaropes have bright females and dull males, which makes sense.
But she still hasn't come up with a passerine, which was
That's
the
right,
question.
a passerine. Come on, Jen, stick with the program here today.
but I just thought we had some answers now.
No, that's great.
address that.
Thank you, Jen. Just giving you a hard time.
Thank you, Dr. Fink.
So more migrants that are very sexually dimorphic are down here. These are tanagers, which again are coming into this area right now. It's also important to point out that a lot of the migratory species that we see during the spring and fall don't live here year-round. They're just passing through when we see them. Even species such as this, everybody knows this one. This actually has in its scientific name that it's a migratory bird. This is Turdus migratorius, the American robin. This is probably one of the most famous migratory birds that we have. It's famous because obviously it migrates very, very well, but they're found all over the place and they're found all year long. A lot of people don't realize, though, because they do migrate, that the ones that are here in the summer are not the same ones that are here in the winter. They are migrating, they're just coming and going from different places. So even though you can see these things in your yard, they nest in your yard, You see them in your yard year-round, you're not looking at the same individuals typically. So they're coming from further north, and they're spending their summers or their winters here.
So what you're saying is, it's the same species, but different individuals
Different
of that
individuals,
species.
right. They're still migrating, they're just not migrating as far. And the reason why is because they eat a wide variety of things. We talked about why individuals migrate, certain species migrate to chase the food resources. Well, a lot of things eat berries and nuts and seeds and things like that, and those are typically the ones that do not migrate because their food source is not seasonal. It's not going to dry up. So these guys right here eat a wide variety of things, so they can eat things like that as well. Worms are also usually active year-round, and so these guys can find worms when it snows or rains and the ground is not frozen. They can find and eat worms during the dead of winter.
So being a generalist can be an advantage.
It is an advantage, and that advantage is they don't have to go near as far when they migrate. So this drawer down here, you can see some of the variation again. So we've got the scarlet tanager over here, where is nice and bright red, very healthy individual male. The females are going to be more drab colored, just kind of a greenish color. And a lot of times, I really struggle with this because I'm not a great ornithologist or birder. Identifying females of a lot of species is extremely difficult. So you can see here is a very young male. You can see the molt is actually happening right now. So if I'm a female, I'm not going to choose this guy to mate with because we know he's not mature.
It's a problem with females everywhere. The males are always so immature.
So these guys right here, this shows a lot of variation as well. These are another migratory species that are coming through in waves right now. This particular species does stay here during the summer to breed, I believe. This is the yellow warbler. The birders that are out there watching right now, there are waves and waves of numerous species of warblers moving through right now. You can go out and see several of those right now, but the majority of those are just passing through. They're just coming down, stopping their migration route to get a bite to eat, fatten up a little bit before they move on. So they're usually only here temporarily during the spring and fall as they're moving through.
Melanie asks, what other species migrate like the American robin? Are they members of the same family?
Yes. So there's lots of them, but members of the same family are going to be the thrushes. So Swainson's thrush is coming through right now. I don't think too many of those do stay in the area though. Things like mockingbirds and brown thrashers, I believe, are the same, very similar. The ones that we have here during the winter are not the same as the ones we have during the summer. So yeah, it's relatively common. One of the last things that I want to talk about is not all species are sexually dimorphic. So these right here are very common. A lot of people know what these are. That's your run-of-the-mill blue jay. Blue jays are not sexually dimorphic. You cannot tell them, as far as I know. Again, I'm not an ornithologist. I just play one on TV. So males and females look very, very similar, and that's very common throughout lots of different species. A lot of sparrow females.
Okay. We just had a little short blip.
We're
good.
Okay.
It's interesting, there are spots downstairs where you get a really strong signal, and then you move 2 inches and you completely lose your signal. Discovered that the other day.
Yeah, it happens.
It's amazing how...
So bear with us.
Speaking of variation,
Right. Variation in internet quality.
within collection.
And then this last drawer down below here is one of my favorites as well. These are some guys that you can see year-round. So Melanie, here you go. Here's another example. These are western bluebirds, no, eastern bluebirds, and mountain bluebirds. So these are mountain bluebirds that you're looking at right now. So again, you're looking at variation in color, which shows variation in sexual maturity and resource use and all those good things. And this is a migratory species as well.
So gee, Ian, if you were gonna guess, which one is the male, which is a male specimen of the bluebird species? Go ahead, point one out. It's a test.
Which is the male?
See if you've been paying attention.
Which is the male.
Which is the male?
Well, I would say something that's darker blue or brighter blue. So I would say this is a good candidate for a male.
What about these guys? Which one's gonna be the male?
And again, look at this variation, just even on the belly. So look how red that one is compared to this one and this one. And this one's nice and red too. So if I'm a female and I have all these to choose from, this one's going to catch my eye, that one's going to catch my eye, and therefore they're going to have more opportunities to spread their genes and mate with females because they're healthier. Again, they have fewer parasites. They defend territories that have nice populations of food resources, things like that.
Very cool.
So that ends our discussion on passerines, the songbirds for the day.
And we, if there are any last minute questions that anybody would like to throw in the comments section, we're looking at them right now. So if you have anything to ask of us.
Is the white on the bellies variation due to age, health, or both?
Both. Everything. All of the above.
All right. That's the last question I've got on
No more
my
questions?
I don't see any more questions.
So we will focus on other groups of birds later.
Cool. What's
So-
next?
I'm not sure yet. What's next?
We're making this up as we go.
That's right. We'll figure that out later.
I just wanted-
We're open to requests, though.
Requests are good. If we know what you guys would like to see, that gives us a direction to go for. So, we're a natural history museum. What about natural history are you interested in?
That's right.
Well, at least within our scope of the great.
We like to crow about natural history.
That's right. Just don't be scared of COVID-19. I mean COVID-19. Again, that's for you bird nerds out there. So thank you for watching. Again, be sure to share, like, all that good stuff. Hopefully you'll see me more often.
We like Curtis.
Thank you. We like Ian too.
Aw. Well, thank you guys for watching. We'll see you tomorrow morning with something. Until then.